my name is Louis.
I'm Tiffany.
And I'm John.
And this is our dog food feeder. Automatic, as you can see. The future is here.
So these were the materials we needed for our project. We needed an Arduino Mega to have our Arduinos communicate with each other through serial communication. So for that, we needed 4 Arduinos, 2 LCD to display varying information, a speaker to play sound, a buzzer for alerts, a button to force the feeder to open for manual feeding, a load cell to measure weight, an LED for status updates, and a servo to control the dog food dispensing mechanism. We also needed something to hold the dog food, so we decided to use a large juice bottle. This is a demonstration of what happens when it's feeding time. We sped up the timer to around 10 seconds to show what happens when the elapsed time has passed.
So the first main part of our dog food feeder is the servo. The servo rotates so that dog food can fall through, or in this case goldfish, so that the dog or person can eat.
Okay, so I worked on the speaker, and how it works is that when it's feeding time, the speaker will play a melody so that the dog knows to come and get food.
So my part is the LED part. So the LED will turn the light on when the feeding time and go off when it's done.
So my part of the project was the load cell, and the load cell was used to detect weight. Load cells are primarily used as a scale to measure weight, but we used the load cell to detect the weight of a dog and dispense food when a dog steps on the load cell. I needed to screw plates on the load cell to have a platform, as well as solder a load cell amplifier to the load cell in order to communicate the load cell with the Arduino.
How the LCD works is that it displays a number of hours before it's feeding time again, and so if we reset it, it'll display 1. There's 1 hour left before feeding time, and then the servo will go off once it goes back to 0.
So we had several problems with these servos. The first servo we had, and pretty much with the second and the third servo too, was that it wasn't rotating. But what we didn't realize is that one of our wires stopped working. And I don't know why, it's like one of the blue wires, and that's why it wasn't getting any power. Once we changed that, then it was getting power and it was making like these ticking noises. And then at that point we realized that the servo needed more power, so we connected it externally to a laptop so that it's receiving its own power separate from this Arduino. And now when we move it, it works fine.
One of the many problems that our team had to overcome during the project was with the servo. The servo we initially had worked out of the box but then broke. Replacing that servo, we got a newer, expensive, but more complicated servo. We thought the servo was also broken, but instead had some more complicated functions. For example, pulse width had to be specified during setup. Truth be told, we don't really know what the pulse width does, but we're glad it works. We also wanted to use the weight sensor to measure how much food was left in the container, the speakers to play a recording of our voice to alert the dog when it was feeding time, but we couldn't get those to work due to our design. The speakers also needed a separate module to set up the recording, so we just decided to use a jingle. On top of this, our wiring was kind of a mess, so there was no way to put all of our electronics on the side of the container like we initially planned.